Okay, so this is the final installment of our set C question. We are left with 3.41b, which we have not solved yet. Okay, sorry, D. Find expectation of x squared and variance of x using the approach in parts B and C. So we need to find the E expectation of x squared using conditional expectation. Same approach as how we obtain E of x using the conditional expectation. So how do we find Ex squared using conditional expectation as well? So if you look at your notes, we'll be using this equation, okay, the expectation of a function using the condition expectation of that function. Okay. Okay, so I've rewritten the equation here. Okay, so you can see, yes, this is the equation, right? I'm trying to use this. Okay, so let's look at this. So Ex squared is also equal to, so we have only two situations. X squared given that first draw is 1. Okay, multiply the probability of first draw is 1 plus. Okay, so let's look at the first part here. Okay, so E expectation of x squared given that the first draw is 1. So first is 1. So this one is equal to x squared. You have, if you look at this, all the way here. Okay, so this is my x, right? The total amount of money we have, and this is the conditional probability. Okay, so using that, oops, now I have written the equation. This is my x squared, so 2 to the power of 2. This is the probability of getting 2 when the first draw is 1 times plus, this is the next one, which you have to consider all possible outcomes that we can get for x. So x squared, another one is 51 squared times 1 over 9. Okay, so that's for condition on the first draw is 1. We also have to look into x squared when the first is a $50 bill. Okay, so here the only possible outcome is 51 squared times 1. Okay. Okay, so next we need to solve what is the expectation of x squared only. Okay, so Ex squared. So if you look at the expression here, now we have found all the conditional expectation. Okay, so we're going to use this to find Ex squared. Okay, using this equation. So I have summation of this multiplied with the probability of getting 1 on the first draw. Okay, so 4 times 8 over 9 plus 51 squared times 1 over 9. Okay. This one multiplied with probability the first draw is 9 is the first draw is 1 is 9 out of 10, right? Plus then we have this, which is 51 squared, and multiplied by the probability the first draw is 50 is 1 over 10. Okay, so this should give me my final answer. Okay, the book says it's 5, 2, 3, 4 over 10. Okay, so don't be alarmed if you have something bigger than 1. As I've mentioned before, expectation is not a probability value. Okay, so it's just a constant value. Okay, so it can be any range. It doesn't have to be limited between 0 and 1. Okay, so the next one is you need to find the variance of x. Okay, so variance of x is Ex squared minus the expectation squared. Okay, so Ex squared we have found to be 5234 divided by 10 minus expectation of x is, okay, this is the value 118 over 10. So 118 over 10, don't forget you need to square this. And the final answer is 384.16. Okay, so please check all my answers. Make sure it's the same as yours. Oh, there might be some mistakes as well. We never know. Okay, so let me know if you have any problem with this example. Okay, thank you very much. Okay, next we look at the next section of the tutorial, which is 3.46. So 3.46 is this. The heat must be removed from a system according to how fast it is generated. Suppose the system has 8 components. Okay, so we have 8, each which is active with a probability of 0.25. Independently of the other. The design of the heat removal system requires finding the probabilities of the following event. So none of the system is active, exactly 1 is active, more than 4 are active, more than 2 and fewer than 6 are active. So from this question you can gather that we have 8 trials, so n equals to 8, with the probability of success, let's say as active, okay, which is 0.25 is equal to the probability of active. Okay, so n trials, okay, so we are looking for none of the system is active. So let's say k is number of success, which is number of active. Okay, so for the first question, so we're finding the probability of k equals to 0. Okay, so we have n choose k, right? So 8 choose none, 0. Okay, and then you have p to the power of 0 and 0.75 to the power of 8. So as I've mentioned before, this is what we need to solve in order to get the answer for A. Okay, so this leaves me, this is 8 factorial divided by 8 factorial, 0 factorial. 0.25 is just 1 times 0.75 to the power of 8. This is equal to, okay, because this one cancels out. For B, exactly 1 is active. Okay, so here K is equal to 1, which is 8. 1, 0.25 times 0.75 to the power of 7. Okay, and the answer is 0.267. Next is C, more than 4 are active. Okay, so you're considering 4, 5, 6, 7, and 8. Okay. So we have so K is 5 until 8. Okay, so finally D, more than 2 and fewer than 6. So 2, 3, 4, and 5. Okay, that's what we need to know to find the answer for D. Okay, so it's more than 2, fewer than 6. So 2 is not included. So it's 3 and above and less than 6. So here you have this. Okay, so of course you need to sum from k equals to 3 until 5. Okay, so 8 choose k. And find the answer. Okay, so this is solution for 3.46.